So, what if the biggest, most mind bending mysteries in physics, the ones that span from the edge of the universe to the tiniest quantum particles, what if they weren't separate problems at all? What if they were all just different symptoms of the same core issue? That is the incredible idea we're going to explore today. A single concept that might just explain, well, everything. Here's how we're going to break it down. First, we'll take a quick tour of the major puzzles that are keeping physicists up at night. Then we'll introduce this pretty radical new perspective called the fabric of reality. After that, we'll put it to the test, see if it can actually explain the weirdness of the cosmos and the quantum world. And we'll wrap up with some seriously mind-bending philosophical questions that this whole idea raises. For decades, it's kind of felt like the cutting edge of physics is just a whole bunch of separate, super hard problems. It's this huge landscape of questions, and honestly, the connections between them aren't obvious at all. And the list, wow, it just feels endless. You've got dark matter and dark energy. That's most of our universe, and we have basically no idea what it is. Then there's all the quantum weirdness, like entanglements, or particles that just magically tunnel through walls. You've got black holes, where all our laws of physics just seem to break down. And what's the deal with particles coming in three distinct families? It's a lot. But here's the big, powerful question. What if we're looking at all of this completely backward? What if these aren't a dozen separate problems, but just a dozen different ways of looking at one single underlying thing? So let's really dive into that idea. It requires a huge shift in our thinking, asking us to completely rethink the foundation of, well, everything that exists. Okay, so the core idea is this. Reality isn't a bunch of different things, particles, forces, fields that exist inside of space and time. No, instead, the idea is that reality is one single fundamental thing. And everything we see, space, time, matter, you, me, all of it, is just generated by that one thing. This really spells out the shift in thinking. The old way of seeing things was like a big, empty box, the vacuum of space. And it was filled with all sorts of different stuff. This new idea says, wait a minute, there is no box. The stuff is the box. The whole shebang is woven together. The huge leap is from a universe of many things to a universe that is one thing. All right, so that's a cool thought, but does it actually do anything for us? Let's put it to the test. Let's start with the biggest puzzles in the entire cosmos. We have to start with the giant, dark matter. When we look at galaxies, we see they're spinning way, way too fast. There isn't enough visible matter, stars, gas, dust, to create the gravity needed to hold them together. So the standard explanation is that there's some invisible dark matter providing all this extra gravitational pull. But in this new view, there's nothing missing. That extra gravity we're seeing isn't coming from some mysterious particle we can't find. It's just an inherent property of the fabric of reality itself. We're not looking for a thing. We're observing a fundamental feature of the one thing that makes up everything. Okay, next up, black holes. These are the ultimate cosmic monsters, right? We think of them as these points of infinite density where our rulebook for the universe, especially gravity and quantum mechanics, just gets thrown out the window and collapses. The fabric idea reframes this completely. A black hole isn't a place where the laws of physics break. It's just an incredibly extreme state of the single fabric. The same rules still apply. They're just playing out in a configuration that is totally alien to us. Okay, so the idea seems to hold its own with the big cosmic stuff. But what about the other end of the scale? If this concept is going to be the real deal, it has to explain the legendary, absolute weirdness of the quantum world. This is maybe the most famous puzzle of all, quantum entanglement. You can link two particles so that if you measure one, you instantly know something about the other, even if it's on the opposite side of the galaxy. Einstein himself called it spooky action at a distance. And here's where the single fabric idea provides such an elegant answer. The particles only look separate to us. From this perspective, they're just different points on the same fundamental object. So there's no spooky signal traveling faster than light because they are already connected. There's literally no distance for a signal to cross. Now here's a deeper, stranger puzzle. Why do fundamental particles seem to come in threes? Take the electron, for instance. It has two heavier, unstable cousins called the muon and the tau. Besides their mass, they're identical. Why three? Why not one or seven? And once again, the fabric model gives us this beautifully simple concept. Maybe they aren't fundamentally different particles at all. They could just be three different kinds of stable patterns or vibrations that the single fabric can have. Kind of like how a guitar string can play a fundamental note and also have stable harmonics. So this idea doesn't just stop with physics. If it's even remotely on the right track, it has these huge, profound implications for how we think about math, about knowledge, and even about our own role as observers of the universe. It suggests this really amazing unification of how we know things. In this view, physics becomes the study of the fabric itself. Mathematics becomes the formal language we use to make distinctions within that fabric, to carve it up. In philosophy, that becomes the study of our own perspective, of how our minds are interpreting the whole show. This also changes how we think about the scientific process itself. Think about it. We start by just describing what we see. Then we build a model, a story, to explain it. We feel that aha moment of understanding when the story connects the dots. But then comes the final and maybe most dangerous step. We start to believe that our model is reality, and we forget that it's just a story we told ourselves. And all of this leads to this truly mind-blowing thought. Perhaps all of physics, all the complexity and laws we see, just boils down to this one simple phrase: the consequences of making distinctions. So I'm going to leave you with this final, massive question to think about. When we choose to draw a line between particle and wave, or between here and there, are we discovering the laws that were always waiting for us? Or are we actually creating the reality we perceive in the very act of drawing that line? It's something to think about.